So they got this alternator sitting in the middle of the room, got all these microphones going to it. They can tell you which bearing is making noise, tell you how much noise is coming off the fan just by the whistling sound, right? Well, we go in the dyno room and the guy starts to turn it up. He goes to the normal 8 grand, everything's just perfectly running fine. He says, would you like to see it go a little faster? Sure, why not? And this is a test chamber. So he starts dialing it up. His eyes get bigger, you know, and I'm watching, my eyes are getting bigger. So all of a sudden we get to 10 grand, I'm thinking, okay, that's it. He said, would you like to see it go a little faster? I said, well, yeah, okay, go for it. Now, this baby's not going to go out of the room. He starts dialing it up. He goes to 11,000, 12,000. He stops at 13,000 RPMs. This baby, if it wasn't bolted to the floor, it's going to leave. But he was showing me where the noise was coming from. The biggest amount of noise, believe it or not, is coming from the fan. You would think at those speeds the bearings would be just squealing, you know. But once he cut it off, we're sitting looking at this thing in a room and you can see the heat coming off of it.
Was it full output at that time?
Full output. It was getting it.
Now, in most what we see in terms of when you start increasing the output, the biggest noise we get is right out of the stator.
Right here is where he was.
Yeah, and the reason that you don't get it out of this is because your segments are so close.
Once more.
The segments are so close. If you the number of count, if you look at your lamb stack, you've got just about twice as many.
Yeah,
maybe a
go
little
back
more.
one more. You can see it
even
really
better.
well. See the iron core here?
Yeah,
Stacking. Look at the stack in there. Look how tight that is.
yeah.
So really a lot goes into engineering of the product.
So the only thing you haven't talked about is voltage drop testing, just to make sure you guys are getting it. It's probably. Do you want me to cover that?
Yeah, to me that's paramount.
Now his Medtronics. Why don't you go through that real quick? There is a meter that actually will test the voltage drop. He hasn't got it hooked up, so
Yeah.
we'll go there.
It'll take a minute.
Yeah, don't worry about it.
Do I need a water or a Pepsi while I'm standing here? Who's what?
Anyway, so the issue there is
Pepsi.
that the Medtronics actually hook up the ground to the ground stud on the starter, and you hook up the positive stud to the clip on the top, and do the same thing to the battery. Is it?
Battery, yes,
Yeah,
sir.
and it actually gives you the readout. It is resistance, but are you loading the circuit?
You are loading your circuit.
Yeah.
You have to load the circuit because otherwise we got open current voltage again, right? So we got to send power through these wires to understand how much of this from the battery is making it up here to the
So
circuit.
that's while cranking when you're testing.
During crank cycle.
Okay. So I also passed out a chart that we actually did for the automotive class up at the tech school, but we actually developed this test sequence.
Let me back up, Dan.
Okay.
It's not during crank. With this meter, I can actually, now with the new Detroits, because the starter's over on the right side, passenger side underneath the turbo, so it's really hard to get to. With the new software, I actually can hook to the alternator, sensing back to the battery, and test all the way from the alternator circuit back to the junction point, which is the main junction here at the starter, back to the battery, and read positive and negative cable to see which one without even cranking the motor. So that's a pretty sweet test.
So what he said was a half a volt maximum drop. Actually, SAE is 4/10 of a volt. So that means your maximum drop on a Class 8 truck or fire apparatus is 0.2 of a volt or 200 millivolts per side. So the question becomes, you can do this voltage drop testing in two different ways. And the only problem with doing it one way and testing your cables is that you can measure you can put your voltmeter here, negative post here, positive post here. And remember, it's the difference between the two leads is what you're reading. So by doing that and then cranking, you will develop a voltage reading. Set your min-max hold if you want, but write down that voltage reading. And let's say that it's 10.8. then go to your battery, and then crank, because I'm here to tell you, if anybody thinks they can do a voltage drop test without loading the circuit, and that means fully loaded, you're kidding yourself. You're not getting nothing. And you wouldn't believe how many times I get a call. I say, "Hey, I got no voltage drop on this battery," and I'm thinking, I mean, from the battery to the starter, and I'm thinking, we don't understand voltage drop here very well, because you will have voltage drop.
Even brand new trucks, you're
Right.
going to have a certain amount.
So you're going to measure the voltage here, and that voltage there, let's say that while cranking, that it's 10.4. So you've gone from, let's say, 10.6 to 10.4. You've got 0.2 of a volt drop on both sides. You got that? That means it doesn't matter what your voltage drop is on either side. So in order to test it and determine then where is the problem, you don't know if it's on the positive side or the ground side at that point. You just know that you're within spec, and that's all you really need to know. But you really ought to do it on every test, because you'll create more problems for yourselves in the long term, as well as everyone else, by not doing it. Especially in the heavy duty market, it's just that important. So when you go from then testing the voltage drop per side, you would measure, it doesn't matter which side of your digital voltmeter you're putting on which connection, because it doesn't matter if it's negative or positive volts. The difference is the same. So you're measuring from the battery positive to the battery positive post, not the cable, but the post itself. Meaning, now on a 31, obviously you're going to be measuring the steel at that point, so you probably want to be on the cable. You can't do much else. So, and then crank, and you're going to get maybe 3/10, and maybe 4/10. So at that point, if you've measured both, which is the easy way to cover both sides at once, and you know you're okay, then you got to, if you're not okay, let's say you got 0.6 or 0.8 of a volt difference, then you've got to determine which side. So you got to go from the positive to positive. So you're putting your meter in parallel with your circuit. And when you're cranking, you're measuring the difference of the voltage between the end of the battery cable here and the end of the cable there. That gives you the drop on that cable. And I'm here to tell you, on the fire apparatus specs that we've worked with the fire departments on in developing, they've got a manual that thick on proper battery maintenance and battery testing on a preemptive scheduled basis, on a PM they call it. But anyway, the bottom line is that we see on one truck, it was this older truck they had out there, and they had a 40 MT in it, which you got to know how old that is. That's probably at least 30 years old. And they were getting like over a volt drop while cranking, and they had 2-aught. No, I'm sorry, they had 4-aught cable on it, and they were still getting too high a voltage drop on this thing. They ended up going to 2 3-aught cables, or just doubling up on the 4-aught cable to get the voltage drop into spec.
Same way from alternator, just as important.
Same
You drop there to make sure the alternator's charging the battery.
Yeah.
We look at this as this is one circuit, that's another circuit. So that has to be just as important, because if it's not coming through the wires back to the battery to charge, this could basically check out good.
And that circuit, same specs.
Same deal.
Yeah, 0.2 of a volt per side.
deal.
Doesn't matter.
right.
So in our method of testing here, we developed this where you write down these facts, right? And you're going to be able to self-test, because you're going to look at this and you're going to say, I see the problem. I mean, it's designed to be able to determine.
Got it on the score if you want.
Okay, yeah, I don't think we can see it though.
Okay.
You can see that each one of them's got one, but you'll see under step 7, it says digital voltage measurement from the negative post of the battery, not the cable, to the frame of the alternator while cranking. That's not a misprint. That's taken the entire ground circuit test away from having to have a future problem.
Start to finish.
Yeah, start to finish, because you're testing the ground circuit. So if it's an isolated ground alternator, which a lot of them all are, I think your 110-555s are isolated ground. So then you go from the ground cable on the back of the alternator to the negative post of the battery.
Let me throw a curve out here.
Okay.
I ran into this on an older international truck that was over 10 years old. Just so happens we were getting ready to leave after talking, had one of the sales guys with me. The guy brought a truck in and he was experiencing some starter issues. I said, "Is that the only thing you're having? Any light problems or anything?" He said, "Yeah, sometimes radio even." So instead of doing what I'm telling you to do, which is battery, starter, alternator, because of time, I just jumped right here to the starter. What is my starter getting? Son of a gun, it was great. But then I got to looking. I had a short ground over to the frame. You could see where the guy took a grinder, you know, and knocked all the paint off. He had a brand new bolt in there. So I thought, usually I'm used to seeing ground cable all the way back to the battery. Well, we opened the battery box. There's the batteries. There's the little shorty ground from the battery over to the frame.
Yeah.
And it was day one battery, you know, at the birth of the truck. There was my problem. Even though this showed good, I was getting ground issues here with the battery. So be careful. Look for all the particulars.
So the truth is, how many trucks use the frame rails for their ground? Most, right?
Freightliner did for the one.
Yeah, exactly. This is an old Navistar that I was looking at.
I know on the marine side of it, we had a problem with the Whatcom Chief. They run that boat across the harbor 18 hours a day, and they were taking piston liners out, and they couldn't figure out what was causing the problem. Were you involved in that?
No.
Okay. I think it was Tri-County was involved in it, and we got involved in
One
it.
engine.
Yeah, one engine.
One of the two.
And what they were doing is they were measuring for zincs and eddy currents, basically, or electrolysis issues that were caused from being in the water, and you're in a bath of acid. Truthfully, I mean it's salt water.
It's true.
So the reality is that they brought the engineers up from Seattle to try to figure out what was really going on, and and they discovered that they thought that what we needed to do is tie the one engine to the other engine, because the grounds, they needed to get rid of the ground problem, is what they thought, and so they did that. The only problem is the next year they had two engines to replace. What it come down to was, you have to isolate the grounds on these engines, and you got to think about this, because anytime you can't pass current through any mixed metal, so you've got steel, you've got aluminum, you've got cast iron, you've got tin, you've got copper, you've got all kinds of mixed metals that you're passing these currents through, and every time you have a mixed metal, you have electrolysis or you have corrosion. Statically in a battery, same thing. It's mixed metal. Always mixed metal creates an outer electron variation, causes heat. And what ends up, I had a Chevy Blazer that I had 0.7 of a volt drop on the ground side. I couldn't find it until I pulled the bolt holding it to the block. So the mounting hole on the block, and I pull the bolt and it's chalky. And what that is electrolysis. So what you get with bisimilar metals running large amounts of current, like 100 amps, through that ground, is electrolysis, which is corrosion times 3, if you want to get right down to it. My background's in military electronics, and you don't want to know about what they do about corrosion control, but it's all the same thing. It's nonstop. So when we're doing voltage drop testing, you can start now on this ground side. Let's take the ground. We can go from there down to the ground cable on your battery. You can say, okay, I've got 0.4 of a volt drop on the ground, and I got 0.3 of a volt on the positive. Let's just say that's true, okay? If you were charging at a set voltage of 13.5. All right, you with me so far? As being the high voltage, and then there are some applications where you're in a 13.8, 13.9 point range on some set voltages, where that's the max voltages. Your battery static voltage is 12.6, and you're, let's say 14 for easy math. So you got 1.4 volts pressure pushing current into the battery. You with me? You got 7/10 now. You got 4/10 on the ground side, 3/10 on the positive side, which is over spec. Now you got 7/10 of a volt resistance to get 1.4 volts pressure pushing current into the battery. Now you're at 7/10 of a volt. Are you with me? Pressure pushing the current into the battery. And you wonder why the battery never gets up to a 12.65 static voltage. They're running the batteries basically at 7/10 of a volt drop, 7/10 below spec. The batteries, how many times do you guys test batteries? Even on my rig that I was telling you about, my battery would never get above 12.4, and I was wondering, why can't I get above 12.4? Well, because I had 7/10 of a volt drop on the ground side. And so the life expectancy of a battery at a full state of charge at 12.4 and never getting up, now talk about your cycle life and the amount of sulfation that's occurring as a result of the sulfur never getting expunged from the plate of the battery. So you've always got a residue of sulfur on that plate that never gets into the electrolyte because you're never getting to the static voltage of that battery. And I'll wager you could be 10-15% of the vehicles that run around here have voltage drop problems. And some of them right out of the factory that don't, I hate to say names of brands, but I can think of one vehicle, I won't say. Anyway, on the positive side, right from the factory, out of the output of the alternator was 5/10 of a volt just on the positive side. Right, factory vehicle. You know, it's just nuts that you see this, and you see it a lot in fire or anywhere where they can save money by virtue of the cost of copper. And anytime you can get that copper directly to the alternator. So now let's talk about this Whatcom Chief for a minute, right? So the problem was they had negative ground cables on that, negative ground alternators on these engines on there. And they were passing current from a cable connection on the battery. Negative was on one side of the block, the alternator's on the other side of the block. So that means that everything in an alternator is returned. So everything that comes out the positive goes around through the battery to the negative. And if you've got a shorted battery, that'll fool you big time sometimes. You'll be able to take an ammeter. I had one time Mercedes, from an old Mercedes specialist that got me. He says, this alternator only puts out 60 amps and it's rated at 90, and no matter what I do, I can't get it above 60 amps. I can, and we take it off, put it on our bench, 110 amps. I can't get above 60 on that rig. I can't believe that. So I came out there, did the same thing. Went out there, put the ammeter, 60 amps. What gives? Drop the voltage. What do you think was the problem? A short between negative and positive in the battery was consuming power, consuming heat. So the problem was just the basics. It's always the basics that we deal with. And it's nonstop, where because he went past the battery test and didn't really determine that the battery was in fact consuming that energy internally. And of course, when he put another battery in, we put an ammeter on it, there it was, no problem. And you wonder, why we miss the obvious more often than we should. But anyway, so when we isolated the grounds and brought the grounds from not going through the piston and liners, which were being destroyed, every year they were putting new piston and liners in this boat and taking it out of service. They, I think, went around 10 years before they had to service those engines the next time. Simply by bringing the grounds off of one side of the block, bringing it up closest to the alternators you can get if it's a case ground, but always better in a marine environment to have an isolated ground. It's always better on any environment, truthfully, if you can bring your grounds directly to the alternator, because it's all going back to the alternator. Every bit of that energy comes out one side, goes back into the other one. So now on a truck, you've got a steel frame rail, you've got all these connections of tin and salt and corrosion and moisture and mud and whatever. And you don't pull the grounds out and take a look at that chalk and put that ground back down on that frame if they're going to use the frame, unfortunately. And then if you have a welding going on a frame, you ever had a headlight or a tail light that doesn't work after they've extended the frame on a frame rail? Why? Because the weld actually cuts the current flow through that frame rail, believe it or not, because of the different structure of that.
That's why they say unhook the batteries when welding on frame, right?
Yeah, that's
a
right.
different story.
So you can move your voltmeter. You can take your two leads, and you can move that voltmeter between the alternator frame and the block. Which I had done that on my Chevy, from the alternator to the block. I would have read 7/10, but be sure you've got that alternator functioning at full output. So you can do that by two ways. One, use your carbon pile, bring your batteries down with your carbon pile, and leave it on there while you're running the test on your alternator, and you'll put out everything that alternator is going to do. So there you let's say that it reads 1/10 of a volt. Okay, well there's 1/10, and you can keep moving it until you find out where your real drop is, for example. But even 1/10 is a fair bit. So if you don't have a voltmeter, by the way, that has in a voltage setting, and this one has one dot, it's a crappy voltmeter. I'll be straight up. It's even worse ohmmeter. But it's a fantastic ammeter. It's the most used tool we have here, by the way. Anyway.
Close to the thousands on the volts.
It goes to the hundreds. I'm set at the DC voltage setting right now, and the decimals, three to the left and 1 to the right. You want 2 to the right minimum. So so your fluke goes 3. Some of them, I think that one's 2, but it depends on what meter. But obviously you're measuring small amounts of voltage. You're in millivoltage readings, so you need to be in those readings. Anyway, the bottom line is you can do the same thing on your positive. You know, it's amazing how many times we'll put the clip, the one probe on the post and one probe on the cable on one that's just corroded as heck, and a whole load test and it not have any voltage drop. And the next one is corroded as heck, will have 7/10 right there. So, I mean, you don't know by looking at it when you see corrosion what your real resistance, but you can measure every problem with a voltmeter by putting the voltmeter in series, and it doesn't matter if it's 2 pieces of steel, the current's going through it back to that alternator somehow. Any questions on voltage drop? I hope if you've learned nothing more tonight, I hope you see the importance of voltage drop and why we see so many problems that we don't get the reality often. And I know they're drilling it into the tech school. That's been a.
I go through it a lot with McNeilus mixers. 'Cause it's all electric. It has to go all the way to the back of the truck, back to the front of the truck, through each connector, so it finally gets down to the coil that actually trips the solenoid, the valve, to do your function.
Yeah.
That you gotta watch. And I've had them guys tell me too, you gotta watch the voltage drop on that.
Turn on the other program.
The other
One more thing I want to get through, and we're almost done here. And that is that Mitsubishi puts a 3-year warranty on their product, and it doesn't matter why you guys didn't check the batteries. That's how good they are. Unfortunately, we'd obviously like to see you understand the basics. The problem that you don't want is to send. They will send a call tag, and up to 3 years, 2 years and 11 months, and they're going to send you a call tag to pick that unit up. And actually, we're going to give you another one, and they'll send the call tag to us, and we'll take care of the whole thing. But at that point, that work order starts again for another 3 years. That's how committed they are. And it's a mathematic deal for them. But the reality is, when you design, their closest competitor is 650,000 B10, which is the engineering term for the first time. 10% of the alternators fail is at 650,000. And yours, as you said, is B10 is 1.5. There's also a B50 where half of them fail. You know, and I don't know.
I think we talk about B10, you know, at the end of that million miles, there's still 90% of them or 10% fail. So that's pretty strong.
Yep. Yep. So it's, you know, from that point of view, I get nothing but arguments out of most of the manufacturers as to whether they're going to cover something, and I don't want to argue. We just want to take care of you. That's the bottom line.
You guys ever use 39 MTs where you have to clock the drive in? And where does your drain tube end up that needs to be at the bottom when you clock it? Facing up, or 9 o'clock, or 3 o'clock?
I don't think they-
The benefit, one of the greatest benefits to the Mitsubishi is that they make a lot of different part numbers so that the clocking will be right for your application, and that drain tube is always facing down and you don't have to clock it.
Always at 6 o'clock. The cool thing about it's not just a tube, it's actually a labyrinth tube. So it can let any moisture out but not let any splash out back inside of it. Whereas some of the other guys, like you said, they'll drill a hole top and bottom, and depends on where you clock it. You can still put stuff in it. They don't like water internally.
Hey, the reality of what we did is we have been reverse engineering everything that we built, and we're able to take that and data normalize that spec, and then basically Dustin has programmed the ability to take and collect that data normalized data and determine 10 degrees on either side of the solenoid. So with the clocking tool, why don't you grab those? We'll give everybody a clocking tool. They're up in my briefcase somewhere. In the computer case. Anyway, we're able to, if you read the clock position on the starter coming off, and the reality is most starters OE are not clockable. They were some in the 42s early, but they only had 2 bolts, and they didn't give you the flexibility sometimes you needed for frame rail clearance. But most OE starters are not clockable. So most of the aftermarket, especially with Remy, are in fact rotatable. And as he pointed out, we even programmed in a 7 to 9 clock position on the drain tube to make sure that no matter what we sell or try to exchange for it, it's by virtue of bringing back the information of every unit that's going to have that clocking with the right drive at rest, with the right pinion count, with the right diameter of drive, with the right drain tube location. So the idea of clocking starters, even the clockable ones, are coming out, whether it be Leesonville or Remy, with a given clock that they think is what, with the number on it, with exception of Leesonville, that is defining the clock position. So, of course, when people change the clock position, then it's a whole new subject. So when we're measuring the clock, and we had to have these made, and we haven't convinced Mitsubishi yet to provide them for us. so we have Remy's name on them, and they ought to be
come on,
ashamed of
man.
that.
Magic marker, I can fix that.
So, if you take and you clock that sucker, you got a flat side which generally goes up against the engine, or
block,
or the one that is open, right? And you'll have an angle nose with Remy, so you got to be careful because you can't clock out an angled nose starter. By the way, you can't clock it out because it's for a high mount. So anyway, but it is rotatable. So the position of the frame then, if you put it on the correct way, This one is 300, looks like about 322 degrees.
Going right to the middle of the solenoid.
So with that, we dial that in. We dial in the basic application or the number that you provide us, and we can get backward to just about anything you want or anything we have. And you'll run into sometimes where you have a clearance issue to your exhaust recirculation, like we've run into, I know. But Mitsubishi, generally, because their OE has got that all figured out.
Yeah, because the OE doesn't ask for a clockable starter. That's the reason why we don't do that. You don't have to worry about when you take it out of the box, put it right in place. You know, this is a handy little tool because if you take the old starter off, you didn't have the new one to get your clocking just right. Now you're kind of guessing. You start getting these components a little close to the block or to the frame because you know your engine can do a little of that. You could cause yourself some damage.
And you can unbolt that and mount it on either side. And you can,
Yeah.
because this doesn't have a ground on it, it's not a grounded base relay, you can actually wire tie it to the side.
She's actually
Um,
here.
Yeah. So it doesn't really matter as long as it's not flopping around on the rig. But
We have some guys that, especially in cold weather, a lot of salt and mac chlorides, they'll actually take it from here and mount it up on the firewall. But just don't take it off and leave it off. It's there really for the particular point.
and why not? I'll tell you, a 42 MT draws 157 amps through the pulling winding on a solenoid. That Mitsubishi and the Remis pull, that's 270, I think. 270 amps through the solenoid. Why is it so high in your minds? Anybody have a good idea? They really don't want that contact not to have a good contact. So they put as much pressure magnetically as they can get into that case to pull that thing up against those contacts.
You've ever seen the contacts in here? They're huge. They're like this wide, so square. But
Anyway, so that pressure, as well as you're pulling in the drive into the flywheel, and they don't want milling. So they want to make sure that that thing gets into the flywheel. So there's good reason for that high current on the solenoid. So now you've gone from 150 to 270, and you think you want to run that back up through your switch loop without a relay on there to bring the power directly off the positive. So all you're doing, little magnet, you got a coil in there, and you pull it right to ground, and it connects these two just like these two. There's no difference between this and this.
Right, just
They're both
size.
relays.
Yep.
And so the more relays you have, the less chance you have for a problem unless you know,
Unless you have a bad relay.
Yeah.
Unless one's bad.
you have a shorted one closed or you weld it. I guess that's possible. But unlikely because you're going to weld that one first, typically. So the reality is that relay is very essential and very purposeful, and no problem if you have one on the flywheel and add another one down below.
Firewall, not flywheel.
Firewall.
Firewall. Good point.
we get excited.
All right. Any other questions? I know you guys all want to go home.
We have, I'm sure you guys all know this, but we have all the data. If you give us what's coming off, if it's a Remy or Elise Neville or whatever's on there, we can get you from Delco Remy to Denso to Elise Neville to Bosch to Mitsubishi and back again. However you need, whatever you guys, it's your choice what you want to put on. But we have the data to get you
Go ahead and pass it.
where you want to go. You guys want one of these wheels? They're a really handy tool. If you use one.
I'm sitting at the floor in the Honolulu Fire Department here last trip over, and we sent a starter out there, and the guy says, this thing won't fit. So I get out there and I look at it, and I say, well, why doesn't it fit? Well, the solenoid hits the frame, and it's a rotatable, I won't say the brand. And it's because that brand didn't have one. Anyway, so the bottom line was, he had never seen a tool because they're so used to taking off brand new OE and putting on brand new OE that they just hadn't understood that they can actually pull the bolts out of the frame and rotate the starter. But the idea of rotation without consideration of the drain tube is absolutely essential. So you got to consider that. And there's one big reason that we didn't have the problem. The 42s never had a drain tube. Did you ever notice that? Why? Because they had so much mass, the differential in temperature
Took a lot of
was
water to fill those up.
was less than a third. So what's going on is we're getting quite a bit of heat generated out of these units, and so what happens when you got a lot of heat and cold temperature, you're going to have condensation no matter what. And you wouldn't believe, but I'm sitting back at a warranty station. I won't even tell you where. And the guy's analyzing the warranty, and he opens up the solenoids, and they're just corrosion all over the place. And he says, water damage. Like it was buried in water. And I'm sitting next to another engineer who'd come from another company. I said, do you think that's water damage? He said, no. You know, it's simply the heat that was being generated and the condensation and how important it is to get rid of that moisture in that starter. Anyway, we're gonna let you guys run, and anybody that would like to have a tour through, you're welcome to walk, and we'll walk you through here in about 5 minutes if you want, or 10 minutes.
Yeah, it just takes a few minutes to go through the shop if you guys want to see what we do here, and we can actually test a unit and show you how our DNV load tester works for our starters and alternators. It's pretty cool. Yeah, I know you guys see